we're looking at the correlation coefficient. So we can see there that we're looking at the Pearson's one particularly, and we have 8 pieces of data, the distance that people walk to work and the time that they travelled. So how far away and how long it takes them, basically. So the first thing we're going to have to do there is for part A to calculate the correlation coefficient, the R value. So before you do anything with statistics, you need to make sure your diagnostic is turned on the GDC. So to do that, you can do second function 0 to go into the catalogue, and then you're going to search down for diagnostic on and just make sure it's on. If it's not on, it won't work. So then we can go into statistics, we can go into edit, and we're going to type in the data that we've been given. Okay, so this one is some old data, so we just need to go over this. So we have 2.2, we have 6.8, so I'm just typing in the X category to the first one and just making sure all of my data is input. There we go. So I'm going to do the same for the Y column. So X is always L1 and Y is always L2. So I have my 2 pieces of data in, and now that I've done that, I can go to statistics, and then I'm going to go across to calculations and linear regression. I'm just going to click enter there, or calculate, and I can see I've got my R value, which is 0.99154. So I'm just going to write this in, 0.199154, and to 3 significant figures, that would be, that would be 0.991 or 992 to 3 significant figures. So for that first part, it's out of 2 marks, and there are 2 marks there for the answer. So you're just using your calculator. And then for part B, it's asking for the linear regression, for the regression line, and that's actually already on my screen here. I can see my regression line is of the form y equals mx plus b. We know that it's a straight line. And I'm told, or in the case of the calculator, it calls it ax plus b. But I'm told that a is 3.2566 here, and b is this one here. So I'm just going to rewrite that. So y is equal to 3.2566 x plus, and then the b value is 6.168779, and so on. And to 3 significant figures for the IB, that would be 3.26x plus 6.17. Okay. So for the second part there, there's 1 mark for correctly getting the first part and 1 mark for correctly getting the second part. And then for question C, it says estimate how long it takes them to travel if they work 10.5 kilometers away. So for C, we're saying that x is equal to 10.5, and we're trying to find what is y. So I can use the regression line that I've just calculated. So y is equal to, and I'm going to use the fuller value to start off with, times the 10.5. So I'm literally just inputting it straight into this equation, the less simplified one, because I want to keep it as accurate as possible. So I'm now adding on my 6.16878. Oops. And if I type that in, that then gives me 40.363, and you can use your calculator if you need to at any of these points as well, or 40.4 minutes. Okay, because we're told that it's calculated in minutes and kilometers. And then for part D, it says that this extra person, this 9th person, travels 32 kilometers to work, and we need to estimate whether or not it's going to be a good answer. Now, yes, the correlation, the R value is strong, which indicates that it would be good, but this is actually not reliable. So it's not going to be a good one. And the reason for that is because we have extrapolated. So this is the key word you're wanting to use here, extrapolation or extrapolated. And that means that the value that I'm taking, the 32, is significantly different and outside the range of the other values. So you can see here, these go to the highest value of 15.2. So 32 is significantly higher than that. It's too large for our data set, and therefore the correlation we found is only for these values, and we can't assume it works for other questions as well. So for this one, there's just one answer mark, and that's for it not being reliable, and you have to give a reason for this. For part C, this was 2 marks. There's 1 for some sort of method if you got it wrong, and then 1 for the answer.